In this video, we're going to factor trinomials when the leading coefficient is not equal to 1. And we're going to use a method called the box method. And basically, it's a rectangle, and we're going to see how this relates to area and the dimensions of a rectangle. So let's get started. So the box framework will always look like this. You will have a box, and in the first box, you're always going to put the first and last terms in these two boxes. They have to go in these two boxes. Then what we don't know really is what goes in the other two boxes. Let's take a look at an example, because it's better to explain through an example than to try to get through the general template of this. So given in this example, first thing we want to do is list put the first and last terms in those corresponding boxes, and then list our ABCs. And what we're going to see here is that this is a candidate for the box because the leading coefficient is not equal to 1. The leading coefficient is 3. Next, what we want to do is we want to multiply the product of A times C, and when we do, we get 36. Next, we're going to look for factors of 36 that will add up to negative 13. Those happen to be negative 4 and negative 9. We're going to take that negative 4 and negative 9, add an x to it, and put it inside of the box. The order does not matter. I could have switched those two out. It absolutely does not matter. Next, I'm going to factor out the GCF in each row, in each column. I'm going to start with that first top row. The GCF is 3x. In other words, 3x is common to both of these terms right here. Next, I'm going to do the same thing with the second row. And what I have to do is I have to adopt the sign of the number, the number that is closest to it. So I'm going to adopt the negative. Next, what I'm going to do is do the same thing through the column. I'm going to look to see what the GCF of this column is. It is x. The same thing with the second column. I can see that it's a negative 3, and again, I've got to adopt that negative. Next, we can throw those into two binomials, and we have our answer. Let's take a look at what happens when we multiply those back out. We see that we have the same exact components of what was in the box. So again, you're starting out with the area of a rectangle, and you're trying to get back to the dimensions or the factors. So this is a way of doing that. Let's take a look at several more examples. So in the second example, we're going to take a look at this. Obviously, this is a candidate for the box method because the leading coefficient is 12. So we're going to put the 12x squared and the negative 2 in the corresponding boxes. Next, I'm going to list the ABCs. Take the product of A times C, and then look for factors of negative 24 that will add up to 5. They are 8 and negative 3. I'm going to throw those factors into the box and start taking out the GCF as mentioned before. In the first row, what's common to both of these terms right here is a 3x. It's a positive 3x because it adopts the sign of the 12, which is positive. Next, in the second row, I'm going to do the same thing. What's common to both of these two terms is a 2. I'm going to do the same thing along each column. What's common to both of these two terms is a 4x. And what's common to the second column is really nothing other than a 1, and we're going to adopt the symbol. And again, we're finished. We just throw those back into two binomials. We can check it by distributing those through, and we wind up with the same exact thing as we started with. Let's take a look at the third example. In the third example, we have 6x squared and negative 2 going in those two boxes. Your ABCs, and the product of A and C is negative 12. We're looking for factors of negative 12 that will add up to negative 11. We throw those into the box in any order, and then start taking the GCF out of each row. And again, adopting the symbol of the number closest to it. So this one's going to be negative. Next, in the columns, we're going to go column-wise. What's common to both 6x squared and negative 12x is a 6x. And there's really nothing common to an x and a negative 2, so we're just going to factor out a 1. Throw those into your binomials and you're done. You can check by multiplying those out and seeing that you have the same thing that you started with, and then simplifying those middle terms. Okay, let's take a look at another example. In this example, we're going to put the 15x squared and the negative 2 in these two boxes. We're going to list out the ABCs, take the product of A and C, look for factors of negative 30 that add up to 7, and as you can see, it's 10 and negative 3. Throw those numbers into the box. Take the GCF of each row and then each column. Throw those numbers into the binomial template and then check it, and you can see that you have what you started with. There's absolutely no guesswork to this. And in our next example, again, let's go ahead and put the 14x squared and the 3 in the boxes. List your ABCs. Take the product of A and C. Now look for factors of 42 that add up to negative 13. And they're both going to be negative 6 and 7. Throw those into the box, adding the x. And again, you can see that the sum of what's in the box is what you really have started with. Take the GCF out of each row, each column, and then throw those back into your binomials. Check it to make sure, and it's done. It's just as easy as that. And I hope this has helped you in factoring trinomials when A is not equal to 1.